This is just to try to help you guys out when you have to solve quadratics that have the difference of two squares. So these are just some examples, and I'm including this set of notes so you can follow along. So make sure that you download it, print it out, or at the very least, if you don't have a printer, then write down the examples on a piece of paper so that you can follow along, and try to leave space on the right side for any notes that you want to add. The top right corner, this is a QR code. If you scan that with your phone, it'll send you to Mr. Ortega's Algebra 1 website, well, his YouTube channel. And with that channel, you guys can watch the videos. This one is already specifically for this type of problem. So on the first one, this is the most basic example that has difference of two squares. Difference means you're subtracting, and then two squares is because x squared is x times x, and 9 is 3 times 3. So the main idea is set up your couple of factors, and then square root the first term, put it over here, square root the second term, put it on the other side, and then the signs here are just one's positive, one's negative. It doesn't matter which one's first or second. So I can put a negative and a positive, and that's okay. Now, if it was an expression, so if it was without the equal sign and it just had x squared minus 9, then you would be able to stop right there because that's factored. If it has an equal sign on it and this is an equation, that means you're supposed to keep going, you're supposed to solve it. So when you have that equal to 0, that's going to be where you're going to keep going, and you're going to separate this into two separate problems. So on the left side, you put this first factor equal to 0, x minus 3 equals 0, and on the right side you get the second factor, make it also equal to 0. On the left side, you're just going to add 3 to both sides, and you find out you get 3 as an answer, and on the right side you subtracted 3. So these would be your two answers. To check your work, to see if it works, you can get that and plug it back in and see that it works out. So if I put a 3 in here, 3 squared would be 3 times 3, so that'd be 9. 9 minus 9 would be 0. 0 equals 0 is a true statement. That means it works. If I put a negative 3 into here, negative 3 times negative 3 is going to be a positive 9. 9 minus 9 is still going to give you a 0, and 0 equal to 0 is still true. So that's how you can check afterwards to see if you got it right or not. On the next example, a little bit fancier, kind of the next step up. So on this one, you have a greatest common factor. If you ever have a greatest common factor, you need to pull those out before you try to do what we did on the first problem. So right here we have a 3 and 75. They can both be divided by 3. You need to factor that out. That means you're going to have x squared minus 25. And then this 3 is going to be in the front. You still have the equal 0 on the right. Now this part, if we ignore this 3 for a little while, this part is just like that first example. So the 3 hangs out in the front. Set up your two parentheses. And then square root the first term. Put one here, one there. Square root the second term, one factor here, one factor there, and then after that the signs, you're going to want to put one positive and one negative, and like I said earlier, it doesn't matter which one's first or second. Once again, this is an equation, it has an equal sign, so we're going to keep going. This first term, if you try to put 3 equal to 0, it doesn't work. If you get x plus 5, set that equal to 0, you find out that's negative 5. And then for x minus 5, make that equal to 0, you find out you get a positive 5. So these would be your two answers. Once again, to check them out, put it back in here. So if I put a negative 5 into here, I'd go negative 5 times negative 5 would be 25. 25 times 3 would be 75. 75 minus 75 is 0. That means it works. If I do the other one with a positive 5, 5 squared is 25. 25 times 3 is 75. 75 minus 75 is 0. Still works out. Next one, this is going to be the fanciest example that you're going to deal with for the difference of two squares. We don't have it equal to 0. That means we need to fix that because we want it to be the difference, subtraction, of two squares. We don't have a difference. We don't have two squares. And on top of that, we don't have it equal to 0. So we need to fix all that before we can do the process we've been working with. So over here, first thing you want to do is get that equal to 0. So subtract 30 from both sides. So if I subtract 30 from 10, I get negative 20, and now I have my 0 on the right side. After that, like the last problem, you have a greatest common factor. You have something you can take out. Both of these can be divided by 5. Factor that 5 out. And now you're ready to do what we did on the very first problem. So the 5 hangs out in the front. X is your first term, and then plus 2 minus 2, and then equal to 0. So just like before, I got the x squared, I square rooted it, 1 here, 1 there. I got the 4, I square rooted it, gave me 2, a 2 there, a 2 there, and then after that a plus and a minus. So if you notice, same steps over and over again, they're repeating. Last part, set them equal to 0, 5 equal to 0, still doesn't work. X plus 2 equal to 0. When you subtract 2, you get a negative 2. X minus 2 equal to 0. You're going to add 2 to both sides. You get a positive 2. Last example, this is a non-example. I want to show you what happens when you're trying to do the work and you find out, I can't do it. So on these, when you find out that it's not factorable, for right now we're just going to say it's prime. So this is an example where our answer is going to be prime. We're not going to be able to find it using this method. But let me show you how you can see that. So once again, you don't have it equal to 0. You would subtract 16 from both sides. You'd have 3x squared minus, what is that, 4 equal to 0. After that, you'd go, okay, well, now I try to find my greatest common factor, and, well, there isn't one. So you're like, okay, there's no greatest common factor, and then that means this is still not a perfect square. That's not a perfect square, so you're not going to be able to use that method for this problem. Now, that doesn't mean you're stuck. If you think about the problem, you can still move that 4 back to the right side. So for right now, we're just going to say it's prime. But if right now you're barely hanging on, then for right now, just say this one's prime and get the practice in on the other problems. On a problem like this, where you can't use the difference of 2 squares, because you don't have a b value in the middle of it, if you move that 4 back over, now you can keep going. It's not going to be a pretty answer, but you can keep going. If we want to get the x by itself, think about first semester, you want to get x by itself, you would divide 3 on both sides so you can get the x closer to being alone. And after that, the opposite of squaring is square root. Be fair, do it to both sides. And that means x could be plus or minus the square root of 4/3. This brings up a whole nother bag of worms. So if you want to keep going with me, I'll show you. But if you don't want to, I completely understand. So over here, the square root of 4 would be 2. But the square root of 3 is the square root of 3. Now, mathematicians, math people in general, do not like square roots in the bottom. You can't leave it like this. This isn't simplified. So the way that you deal with it is you multiply by another square root of 3 on the numerator and the denominator. And when you do that, on top, you're going to have 2 square root of 3. And on the bottom, now you have 2 of them inside the square root, so it comes out. And this thing that I did with the plus and the minus, that's going to be any time that you use a square root to get rid of a square on a variable, you're going to put that. So your answer, for those of you that kept up with this and that you persevered, your answer would be, as ugly as that is, that's your answer. So if you have questions, you have me on Remind, you have me on Google Classroom, let me know. I'll try to help you guys out.